Okay, hey, uh, let me turn on. Okay, let's take a look at this week's lab exercise quickly. I'm gonna just, I'm gonna, I'm gonna briefly introduce you and guide you what to do for this week's lab exercises. Luckily for the lab exercise number 1, no submissions, and for the lab exercise number 4, it's kind of your preliminary preparation for the rest of project entitled the Yonsei University Campus Modeling. Okay, so before getting started, I would like to bring your attention using this one, Revit 2020, just released. Okay, what's new? Revit 2021. Okay, under the Autodesk website news, there is this page, as always, also published on one of the Autodesk products website. And let's quickly take a look at this one just for your information. Okay, in this page we can easily find out what are new features in this newer version of Revit and which one is kind of enhanced from existing one. As I mentioned before, in the middle of spring, usually middle of the spring semester, the next year version released. So let's take a look at this one, something enhanced. Just for your information, let's take a look at this video quickly.
The ability to visualize and communicate designs in 3D has long been a key value proposition of BIM for architects.
Something about some visualization enhancement.
With real-time realistic views in Revit 2021, architects can understand and assess the visual impact of their designs directly in the Revit authoring environment, enabling them to more easily communicate design intent with.
So basically, Revit has real-time realistic render visualization as one of the default views in 3D view, but this one says it has kind of bigger enhancement
With stakeholders and collaborators.
And it looks very stable and fast.
This new feature replaces the previous realistic mode for all types of views and sheets, enabling you to design, modify, and document your building with realistic materials and lighting. Materials appear more convincing, and automatic lighting exposure removes complexity.
I see this one has a new feature, kind of realistic visualization. To support realistic visualization, it can change the color mode or some color tone using some reference images or some preview images and so on. So anyway,
Complexity and confusion when moving from outside to inside the building.
I see there is a kind of paper airplane view, something like that. So probably it's kind of not only for human eye level walkthrough, but also kind of freely moving in the air, I mean the inside of this space area.
Best of all, view navigation is much faster and smoother, performing over 10 times faster than in previous versions.
Okay, I'm not sure it's true, but anyway, he says 10 times faster from previous version. The previous version here, of course, 2020, now we are using. Okay.
Walk through realistic models with your clients in real time. Work directly in better, easier, and faster realistic views in Revit 2021.
Okay, kind of very hugely enhanced visualization and generative design. Okay, let's take a look at this one as well. Before getting started, for your information, generative design is one of the advanced parametric modeling approach. As generative, the term generative literally means it's kind of auto-generation. If you want to create something new geometry, you're supposed to draw something or define something. Anyway, you have to put a specific algorithm. And then computers, software such as Revit, going to represent what you intended. right? That's kind of formal approach of design. But actually, the next week topic we have some series of design by numbers using visual languages or script languages, something advanced parametric design approaches using Dynamo. Dynamo is a Revit version of Grasshopper. Probably some of you may know Grasshopper plugin on top of Rhino. It's really common, popular, powerful tool nowadays for especially for freeform design. But even further development on top of that kind of language-based design, one of that is this one, generative design. Actually, the concept of generative design is kind of long lasting. Even when I was a student, I studied and took a look some features in generative design. At the time, I used some parametric studio, Bentley systems, and some generative components, so-called GC. Nowadays, some companies use that GC tool for parametric design and modeling. But anyway, probably this video will introduce you how Revit 2021 newer version adapted that kind of advanced generative design features. For example, auto layouting or some kind of optimized layouting or simulation supported design suggestion by Revit. Not only yourself, but also Revit is a kind of assistant, not just a simple computer tool. Okay, that's kind of eventual goal of generative design or something like this one. Okay.
Generative design is a design exploration process to quickly generate and evaluate high-performing design alternatives. Until now,
Okay, now I see. It's kind of simulation integrated design approach. For example, if you change the rotation of the layout for the furniture or something, interior facilities, whatever, this one will simulate in real time and displays the result in visual output as well as the actual performance using their property numbers. Sort of simulation. Simulation goes with calculation. So that kind of calculation results going to guide you which one looks better as well as which one is high performance or something. So that is why this one is simulation, or in other words, sort of design optimization process. That's what
many generative design tools have been hard to use because they required our customers.
As you see, the slide bar here and the node and some lines connected between the nodes, the boxes here. This is Dynamo, geometry, Dynamo, manipulation. So next week and next after next week topic, lab exercise topic going to be, and the lecture topic going to be this Dynamo. So it's kind of not that easy. It's difficult especially for beginners, but this is inevitable. Very useful and powerful kind of advanced parametric modeling approach we have walked through last week. So anyway, this is a good preview, I think.
To know how to code, understand special terminology, or know how genetic algorithms work. Now you can use generative design directly in Revit to quickly generate design alternatives based on your goals, constraints, and inputs. Revit Generative Design provides a set of sample study types to demonstrate how this tool can be used to generate outcomes for design challenges. You can easily run one of the predefined studies or recipes in Revit Generative Design, such as workspace layout or massing. Let's suppose you want to determine the best arrangement of desks in a large room. Your goals are to maximize the number of desks while also maximizing views to the.
Okay, for saving time, let me pause the video. I think this generative design feature is, I believe, it's a really, really useful, powerful tool, especially for interior architects, interior designers, and planners. For example, if you have a new plan for a retail store, how to maximize the circulation performance, or how to maximize your sort of economical factor. I mean, some beneficial layouts against some convenient layout, something like that. So how to compare them with the numbers, with evidences? This one going to be really useful tool to provide you such evidences, because this one totally based upon various type of design alternatives and their analysis results going to be given for your report or something. Anyway, this is another one, extended one from the last week. Design for X. This one at this time, design for optimization, or design for better design alternative selection, or simply design for decision making, right? As a decision making or decision support tool, Revit is something like that, something beyond just design representation tools like SketchUp or something. Okay, let me close. And some electrical circuit, customized workspace, slanted word. Slanted means angled. You know, our wall is always perpendicular, 90 degree against the floor, right? That's the wall object, but angled, diagonal shaped, something looking very dangerous. But anyway, nowadays a lot of freeform shaped buildings and this kind of slanted walls required, and probably Revit wall objects updated for modeling this one. Dynamo 2.5 integration, blah blah. Lots of things enhanced or newly implanted on top of newer version. So please take a look at this kind of pages and so on. Let me go back to the slide. For the lab exercise number 1, this is geometry exchange example, no submission. But it doesn't mean that you don't need to do anything. We actually have done this one before, some geometry import and export. Let me show you an example. Before doing that, let me introduce you our lab exercise folder today. This is the lab exercise folder today. On the lab exercise number 1, just for your information, I added this one, OSM. From OSM to OBJ, converted to 3ds, 3D Max, FBX, DWG, and Revit. So just for your information, actually we have walked through this one. But my intention here is, let me open this one. As you see, Revit 2020 now loaded this imported geometry, right? As you see, this is Sinchon site. We already used this one. Some slab object and some components, trees, modeled like this. If I open this one in elevation, let's take a look. This is the slab for the floor. Okay, these are BIM model and imported geometries here. And let me open another one, another resource. Under the resource folder, there are many files. I actually loaded more than 200 megabytes 3D Max file. On the 3D Max, there are several. You can see the preview right side. Some furniture components, just for your information, they are just mere geometry when you load these into Revit. And second folder in resource Revit campus building. Okay, mid-size campus building example. This is Samsung Hall building as well. And small building example. Example, Sinchon building 1 and house 1. Okay, I need to open this one. Sinchon building example that I gave you before. So this one is almost looking similar to the former one, but this one has small building model like this. Okay, so just for your information, let me export this one at this time using geometry format. On the export, take a look. There are something like this, okay? CAD formats. On the CAD formats, DWZ, DXF, DZN, ACES, and DWF, FBX. I have a strong recommendation to use FBX file, especially when you are using Autodesk tools, especially 3D Max. FBX contains Autodesk material and some texture data, so you can take advantages of Autodesk material, Autodesk texture, while you are render in different application in Autodesk family apps, okay? And GBXML, IFC. Now you see the IFC. Actually, IFC file is a text file, but that's why it's kind of very heavyweight, very big file size. But we don't need to use IFC at this time. Let me export this one in DWG format. If I export in 3D view, as you see the screen, now we can export this one in DWG format in 3D. Okay, let me cancel it and I'm going to show you. If I open level 1, as you see, this is level 1 floor plan view. It doesn't mean that model is 2D flat. It's 3D, but current view is 2D flat. So what if I export the same task I have done formerly? Let me click the DWG export again and take a look. What is this? If you open this DWG file after exportation in other tools like AutoCAD, and then you can realize that this is real 2D. There is no missing 3D information, 3D geometric data. That means your current view and your export makes some different results, okay? So if you want to export this building 3D geometry as well, you have to export your DWG or any other geometry format in this 3D view, okay? That's the point. So let me do this, okay, in this 3D form. Next. And okay, you can choose the AutoCAD version. Lower version, safer. So let me choose 2010 version on the specific folder. Let me export. It takes a little bit time, but finished. So let me take a look. The folder, okay, 7 megabytes DWG file just created. It's 3D view. So the reason I exported this one, actually we can import that 3D file in SketchUp, Rhino, 3D Max, anything else. But for your information, let me quickly re-import this one again to Revit. Just simply drag and drop. Let's take a look at what happened. It looks like something similar. Let me a little bit overlapped like this. Okay, now you see here is the same, exactly same looking geometry, right? But if you click this one integrated single geometry, and you can find out this is imported symbol, imported objects, named this blah blah 3D view 3D.dwg file, okay? And the original file, as you see, this one has wall, slab, and imported geometry and 자전거 rack 2 objects and 휴지통 정사각형 objects, okay? All these are object based and exactly same geometry, but this is the information set all broken. But take a look. Let's compare this one, this object based Revit model, zoom in some patterns, and let me show you this one, this geometry. Anything missing? Okay, the reason I tested this one, exported geometry from Revit and imported geometry from Revit, this is an evidence that Revit created geometry is very stable and very how can I say, the perspective of the geometric perfection, this one has almost close to 100%. What I mean is, you have a lot of experiences when you export your geometry from SketchUp to other Max or Rhino, or even same SketchUp. Sometimes your geometry is missing. For example, the surface of the top gun, or this wall side, or some complicated shapes like these leaves in the tree, something all missing. You don't know why, but that happened before. But in Revit, precisely, the geometry created by Revit, it's really, really stable. Because Revit totally based upon calculate geometry basically using solid 3D. So what is solid 3D? Solid 3D has very, very how can I say, the very strict convention and rules for defining geometry. In other words, some unclosed cubic box, it's impossible to be modeled in Revit. You saw a lot of some alerts or notifications from Revit. Basically, Revit has very stable geometry definition because it's based upon solid 3D. That is why Revit exported 3D geometry has really stable and nothing's missing. It's really, really 100%, actually not exactly 100%, but close to 100% non-problem geometry you can make if you use Revit. That's the point, okay? And that's why I put this one again from your former things, okay? So please take a look at resource folders, and the rest one, lab exercise number 2 and 3, you have series of rest of 2 more videos for this one, for doing this one. They are another extended versions from last time. They are something about parametric modeling, okay? Lab exercise number 1, no submission. This is kind of review. Lab exercise number 4, this is a preview. And for your convenience this week, I like to some lightweight lab exercise I want to show you. That is why extended version from last time, parametric modeling for lab exercise number 2 and 3. Instead, you have to take a look lab exercise number 1 again, using given examples here, okay, on the resource folder. On the Max folder, you can find out some geometry. In campus building, mid-size, you can find out Samsung Hall and one of the post-tech buildings. In the small buildings, you can find out some house buildings. Please open them and try to export, import, or take a look some details about that given model. And some Revit family files, Herman Miller, Aaron Chair, and some office workstation layouts. They are very useful for office layouting, office decoration or something. Just for information, I loaded. And as always, some 3D warehouse objects, well, downloaded, SketchUp file. You can test it and you can reuse it for further development according to our quick discussion and near future rest of discussions for picking up your final project. Which building is your subject or something that should be fixed, and then we are going to move on. Okay, thank you.